Hmm? Name them, we call that chemical formula for that particular molecule. Okay. And chemical formula tells us, what that molecule is. For example, when we say H2O, it means it is water. And in H2O, there are how many hydrogen atoms? 2 hydrogen and 1 oxygen. Okay. So every molecule will have this kind of different formulas. And then we can compute how many a particular atom is there. For example, we have NH4 to FO4. So NH4 to SO4, right? This is slightly complex looks like, right? But because this is in bracket, so in this formula, we are going to say we have 2N, okay? And 2 into 4, 8H, and then 1S and 4 oxygen, okay? So there are 4 different elements here. This is nitrogen. This is H is hydrogen. S is sulfur and oxygen, okay? As you can see, 4 different kinds of molecules combining in different proportion also, right? 2 nitrogen, 8 hydrogen, 1 sulfur, and 4 oxygen. Okay, so like that we have to do. Okay. Now there are 3 kinds of formulas. The same thing could be expressed in 3 different ways, right? So first is the chemical formula which you have seen like H2O, NH4SO2, CS3, H8, etc., etc. Right? That is the very simplest one, the chemical formula which we use. Second is what is called structure formula. Right? So in the structure formula, we show how the molecule actually looks like. Right? So for example, H2O will look like there is 1 oxygen and there are 2 hydrogen. Right? It is again H2O only. Right? But this time we are showing it where the atoms are combining with which one. Okay. So this kind of thing is what we call structural formula. Okay. And this is simply our chemical formula. Chemical formula. Okay. Now the structure formula could looks very complicated, like the molecules we have seen, right? It could be very complex molecule as well. So they can look something like this. Yeah. You have this carbon here. Then you have hydrogen here, right? And a hydroxide here, which is hydrogen oxygen. And then again, OH group, CH2, like that. Okay. And then you can make it look simple by just removing the carbon like this, make it look like a ring here. Okay. And here is the oxygen, no carbon. So we are showing the oxygen like that. Okay. So there are different ways to draw the structure formulas, right? It could be very, very complicated, but for now, you just have to know that, this is how it is. Okay. You're not required to draw them right now, but this could go complex. But for the simple ones, hydrogen, we can have a structure formula, which is HOH, which shows that the 2 hydrogen are side by side to the oxygen. Okay. Fine. H2O2, hydrogen peroxide, we have 2 oxygen connected to each other, then 1 hydrogen connected to another oxygen. If we just say H2O2, we don't know how they are arranged, right? We don't know how they are arranged. But when you draw it, basically you can see that 2 oxygens are connected to each other, and then 1 hydrogen is connected to the oxygen. Okay. We have CCl4, right? Carbon tetrachloride. We have the carbon at the center and the 4 chlorine, right? These are chlorine attached to that, right? We can have more complex C2H5OH. So we have this 2 carbon there. Then we have 3 hydrogen on this side, and then 2 hydrogen on this side. And then we have oxygen, and then we have hydrogen, right? So as you can see, the structural formula is going to give us more information, right? More information about how atoms are arranged in a molecule. Okay. All of these are molecules, right? Then we have innovative one, which is ball and stick model, which is sort of a 3-dimensional. Okay. So in structure formula, we are just saying hydrogen, oxygen, hydrogen, right? But where they are. So in the ball and stick model, oxygen is here, hydrogen is here, like that, right? It shows in the 3-dimension how it will be. Okay, so this 3-dimension and 3-dimension. Okay, you have ball and stick. Okay, this guy here is oxygen. One hydrogen is on that side, then oxygen, then another hydrogen on this side. Can you see that? This is outward, this is inward, right? We don't get that information in the structure formula, but when we go to ball and stick model or 3D model, you can exactly know where it is in the 3-dimension, right? And the CCl4, basically you have this carbon here, another chlorine at the top, and then it is forming a tetrahedral structure like this. Okay, so these are structural formulas, and it will, as you expect, it will become more complex and complex as we go along. Just for example, you have seen something like this, right? Which seems to have a very complex structure. But right now, we are just going to take a look at it, right? We are not supposed to know all of this and how to draw this. That we'll do later on when we have more idea. Okay. Now, so these are direct atoms basically connecting with each other through something called covalent bond. But we could have a different situation where one atom, something like sodium or chlorine, etc., right? So if you have studied a little bit of atomic structure, you will know inside the atom what is there. There's a nucleus where you have proton and neutron, and then you have electrons, right, in orbits like this. Okay. Somehow, if we kick off one of the electron out, then what will happen? It will, we say it as a positive charge. Okay. And if somehow we get extra electron over here, we say it a negative charge. Okay. So this kind of a situation when the atoms become charged, we have a name for it, we call it ions. Okay. Charged atoms. So we have Na plus and Cl minus, which means Na has lost one electron and it is now positively charged, and Cl has gained extra electron from somewhere. We don't know from where. So it is a negatively charged. Okay. The magnesium could lose 2 electrons and become doubly positively charged, like that. Okay. And there are several. But the idea is that they have positive and negative charge. Okay. Anybody knows about electrical forces? No? Okay. So that this point we have to introduce simple idea. So we have two kinds of charges. Okay. Only two kinds of charges. Two kinds of charges. Okay. And we can confidently write only two kinds of charges. Okay. One is positive, another is negative, right? And then law of electrical forces, or Coulomb's law it is called, right? It says very simple thing, right? If you bring together positive and positive charge particle together, they will repel each other. Okay? If you bring together negative and negative charge particles together, they will again repel each other, right? They will try to go away from each other. Coulomb's law. Okay? But if you bring one positive and negative charge together, they will attract each other. Okay? So they will become friends and they will attract each other. Similarly, you become negative and positive charge together, they will attract each other, right? How much will be that force that we can determine using Coulomb's law? That we'll look into the physics, right? Which is K Q1 Q2 by R square and things like that. But we all you have to know right now that like charges, these are the like charges, positive and positive, like charges repel, right? And unlike charges attract. Right? Very simple. Now, as you can see, our sodium, which is now positively charged, okay? And we have chloride, chlorine, which is negatively charged, because they are positive and negative by virtue of our law of attraction here, they will attract each other, right? And basically come and stay at certain distance from each other, forming a compound, right? A compound. So all the negative and positive charges, they will attract each other and try to form a compound very naturally, right? And this kind of compounds have a name. They are called ionic compounds. And today we'll see how to name them, right? Or nomenclature it is called, how we can name this ionic compound. But before we go there, basically see this is how it is structured. So you remember you saw that structure like this, right? So these are, in reality, if you look at just the NaCl example, we have this like that, okay? So we have one Cl molecule inside, and on the all the four sides we have, sorry, a 4 Cl molecule inside, and then we have on the side you have sodium, right? And they form sort of a cubical structure like this, okay? Packing, like packed with each other, right? So each sodium chloride consists of extended array of equal number of sodiums and chloride ions, right? So you have the sodium, which is a small sphere, and the chloride happens to be a bigger sphere, just like that. This is just for illustration, okay? We have sodium and chloride forming like that, okay? So ions and ionic compound, right? So ions are atoms or group of atoms which has electrical charge, either positive or negative, okay? Either they have positive charge or negative charge, right? We give example of one atoms, but it could be group of atoms also. Like for example, OH. OH is a group of atom, right? We have oxygen and hydrogen, we have a negative charge there. Okay, that's called hydroxide, for example, right? When they have positive charge, we call them cat ions. Cat. Cat comes first, and when they have negative charge, we call them anions. Okay, the cations and anions. Positively charged one is cations, and negative charge one is anions. Okay, why they are positive? Because possibly they have lost electron, and that's why they have become positive. Anions, they have gained electrons, and that's why they have become negative. Okay, and the idea is how to name them. But before, so what happens when a positive and negative charge, for example, is sodium and chloride coming together, right? Sodium has one positive charge and chloride has one negative charge. They come together, the charge finally becomes zero. 1 plus 1 minus 1, right? So here you see the sodium has one positive charge and chlorine has minus 1. Sum is 0. Okay. So whenever a molecule like this or ionic compound will form, okay, whenever the ionic compound will form, basically net charge has to be 0. Okay, that's our idea number 1 or rule number 1. Okay, the net charge must be 0. Okay, and then we look at different ions which are readily available. I will encourage you to copy this table very quickly. In a place where you can refer to it very easily, because you're going to refer it several times. Okay. On the left hand side, you have common cations. First one is Li plus, which is lithium. Okay. Coming out of the lithium atom, Li plus charge is plus 1. Right. Write down. Then we have sodium. Then we have K, which is potassium. Potassium. Then we have group of atoms or molecule here, NH4, right? It is called ammonia. Okay. It also has one positive charge. Then the silver, which is Ag. Silver, Ag plus. Then we have some of them with double charge: magnesium 2 plus, calcium 2 plus, zinc, which is 2 plus, copper, right, has a one charge here, and copper could have two variations. One is singly charged, second is double charge. So Cu plus and Cu 2 plus. Okay, we write it like that. And then you have iron, ferrous, Fe 2 plus. Okay, so in the copper, when you have plus 1, we write it in the bracket copper 1. Okay, when you have two charge, we write it copper 2 in the Roman numerals. And then the iron, either you could have 2 or 3. So iron 2 and iron 3. Okay, ferrous 3, ferrous 2. And then we have aluminum, which is Al3 plus. These are called cations. Cat comes first. Okay, that's positive cat. Now on the right hand side, you have F dash F, that is fluoride coming from fluorine. They have Cl minus, which is chloride coming from chlorine, right? You can see here, this side was same name of the element. This time it is coming with DED. Okay, a slight variation in that. Chloride, fluoride, bromide, iodide, hydroxide, then acetate, nitrate, like that. Okay, ending with E usually. So you have to remember this convention basically. Then we have O2 minus, which is oxide, S2 minus, sulfide, SO4 2 minus, sulfate, SO3 2 minus, sulfite, CO3 2 minus, carbonate, and then we have PO4 3 minus, which is phosphate. Okay, so these are the main ones, and you should know them. Okay, so slowly with practice, you will start remembering them, and finally, our expectation is that you will know them by heart. Okay. Okay, so we'll move on, right? We'll come back to this table, then you can fill up whatever is missing from that, okay? So now, our first one was Na and Cl coming together, okay? The first thing you want to note how much charge is there, okay? So in Na there is 1 and Cl is 1, right? To make them 0, right? To make them 0, we just need to combine 1 sodium with one Cl, right? Na plus is called, we look at the table, Na plus is simply called sodium. Okay, so we first name the cation always. Okay, so this is sodium. Okay, and then we have Cl, right? So we are going to bring the Cl in. Cl has how many charge? -1. So my charge is 0. That's called chloride. We are going to name this compound sodium. Okay. So name of NaCl will be sodium chloride. Okay. Another easier one. KOH. Okay. So K has how much charge? Here, 1 charge. And OH has how much charge? 1 charge, which means only 1 and 1 will combine, right? To make it 0. You see that? Yeah. Net charge is 0. This is called potassium, right? And OH is called what? Hydroxide. Hydroxide. Hydrogen and oxygen is there. This is called potassium hydroxide. Are you getting a gist of it? How to name them? First, we have to name the cation, followed by anion. Okay? Potassium hydroxide. Just like that. Very easy. Okay? And as you can imagine, that the ionic compound will form only with positive and negative. We cannot have sodium, potassium, right? Because those are positive, they will repel. We cannot have chloride and hydroxide because negative, positive will repel, right? It has to come from the positive side and negative side. Net charge has to be 0. Fine. That's the idea. Now I will do some of them, slightly complicating looking one. Okay. So we have this NH42S. NH42S. So we look at NH4, which is positive, right? We have this NH4 with 1 positive charge, and then another is S. S is -2. Okay. My S is -2. Correct? So in order to make the charge 0, because this is -2, I have to bring 2 of these guys, no? Right? So 2 of these will become +2, and then combined with S, -2 will become 0, right? Net charge has to be 0. That's our rule number 1. So we have to bring these 2 guys, right? So we have to basically do NH4, 2 of them, and then S, right? And that is our compound. We have to name them, right? So first we have to name with the cation. Which is the cation here? Which is cation? NH4 or S? NH4, right? NH4 is our cation because that is positively charged, right? So first we have to name that, right? So when naming this, we have to start with the cation. So NH4 is what? Ammonium. Okay? So we say it, ammonium. And what is S called? Look at your chart. S2 minus sulfide, right? Ammonium sulfide. Cool. There's no complex, but it's very simple. Okay. Now we look at another one. We have this copper and NO3. Okay. So copper has how much charge? Here it is. It could be either plus or +1 or +2. We don't know. Right. So we look at the other side. Right. So we don't know it is either +1 or +2. Right. We don't know which one it is. So we have NO3. NO3 on this side is NO3 nitrate, right? Which has -1 charge. Okay, so this one has -1 charge for sure. Okay, Now, in this formula, we are getting 2 of the NO3s, right? So net that is going to become how much? -2, no? 1 NO3 becomes -1. There are 2 NO3s here, which means this is -2, right? So the copper, to make it 0, has to be the copper 2 here. Yes or no? Copper 1 cannot make it 0, correct? We have to have that copper 2 over there, right? So we start naming by cation. So we look at the copper 2 first, which is copper 2. Okay? So my name here is going to be copper in the bracket Roman 2. Fine? And NO3 is called nitrate. NO3 is called nitrate. So we write copper 2 nitrate. That's the name, CuNO3 2. Okay? Fine? So now we look at happening. Is refusing to get erased, seems. Okay, fine. Now we are fine. So that's our ZnCl2. Okay. So Zn is what? Zinc. How much charge? +2. Right? +2. We have this +2. And then we have Cl, which is chlorine. Okay, which has a -1 charge. Okay. Right? So of course, this is a +2 charge. The chlorine has only -1 charge. We have to bring in 2 of the chlorines to make the molecule possible. Right? That's why it is ZnCl. Okay, to make the charge 0. That's it. Right? What will be the name? We look at the cation zinc. Zinc first. Okay. So that's our zinc. And Cl is what? Not chlorine. Look, chloride. Right? Low. You see that? Zinc. And Cl is chloride, not chlorine. Okay. This is an ion, right? So ions and ions, we have a special way of naming them. Fine. That was pretty easy. Now we have Fe2CO3. Oh my God, that looks very complicated. But again, it is very easy. First, we look at the Fe. It will get deleted. Okay. So we have Fe2 and CO3, 3. Okay. So first look at the Fe. You have your Fe over here. Yes, we have, but Fe could be in either 2 or 3. Okay. So we are not sure how many we have to use. So Fe could be either +2 or +3. We don't know which it is. Okay. So we have to look for the other thing. CO3. CO3. Yes, we have CO3 here. Okay. It's coming with how much charge? -2. Right? CO3 is coming with charge -2. And we have 3 of them. Right? We have 3 of them. Right? So how much charge? 3 into -2 will be how much? -6. Okay. And how many Fe's there we have? 2. So to make to -6, make it 0, we have to use Fe3 or Fe2. We have Fe, 2 of them, right? In order to make it +6, we have to use Fe3 or Fe2. Fe3, right? Then it will become 3 into 2 is equal to +6. And other side is -6, and that end result will be 0, correct? So we have to definitely have Fe3 over here. And what is the name of Fe3? Iron 3. Okay. So here the name is going to be my iron 3 in the bracket. And then CO3 is what is this called? CO3 carbonate. So this is iron 3 carbonate. Make sense? Right? This is slightly harder now, right? We have to judge whether we have to use the number 2 or 3 or 1 or 2, depending upon if we are not sure, we have to go to the right hand side to check which one they are using. Okay. So now we go other way around. We have the name and we have to write the formula. Okay. Here we go. Sodium fluoride. Right. So first is our sodium cation. So we go to the list and find my sodium, which is Na plus. Okay. Sodium, which is my Na plus with one charge. And then we look for the fluoride. Fluoride is what? F minus at the top. Okay. So we have this F minus. Okay. So plus 1 and minus 1. So we just combine 1, 1 and we are good, right? One sodium and one fluoride, net charge will be 0, right? Right. So my formula for sodium fluoride will be very simple, NaF. Yeah. Now look at calcium fluoride. Please write it down. Calcium fluoride. Calcium, what's the cation for the calcium look like? Ca 2 plus. Yeah. So we have calcium 2 plus and fluoride is F minus. Okay. So to make it 0, how many calcium and how many fluoride we have to combine? 2 fluoride and 1 calcium, correct? To make the charge 0, which means the formula for this is going to be calcium F, not CAF, CAF2. You see that in the sodium fluoride it is NaF, in the calcium fluoride it is CAF2. Now we go iron 2 sulfate. Okay, so we go back to our table. Iron 2, what is the symbol formula? It's man iron 2 formula. Not copper, iron. Fe2 plus. Okay. So this is Fe plus 2. Okay. And sulfate, SO4 2 minus. Sulfate, SO4. Can you see that? So we have this SO4 minus 2. Okay. So how many of them we have to combine? This is plus 2 and minus 2. 1, 1 will do, right? 1 iron 2 and 1 sulfate will do. Yes or no? This is plus 2 and minus 2. Right? So what will be the formula? FeSO4. Fine? Like that. Okay. Now we go zinc phosphate. Okay. So in your table, what is the zinc? Zn plus 2 plus or 1 plus? 90. Zinc is 2 plus. Okay, fine. So Zn plus 2. And then we have phosphate. Myra, what is the phosphate? Phosphate is towards the end here. PO4, PO4 3 minus. Can you see that over there? PO4 minus 3. Right? And now we have this odd and even number there. So we don't know how to combine them. Right? So what we are going to do? We are going to take the LCM of 2 and 3. Okay? LCM is how much? 2 and 3? 6. Which means we have to have 3 of the zinc and 2 of the PO4. Correct? You agree? To make the charge 660. Right? So we have to have 2 zincs here. So Zn2 and sorry, 3 zincs there, right? Zn3. And then how many phosphate? How many phosphate? 1, 2, 3, 4. How many phosphates? It has a -3 charge, right? And we want total charge to be 6. How many phosphate? 2, right? You have -3. Here you have +2 into 3. That's +6. Okay? We want this side -6, right? So we have -3 into 2 now. We'll make it -6. And net will be 0. So Zn3PO4 2. Like that. So that's our formula for zinc phosphate. As you can see, it is becoming complicated as we are going along. Zn3PO4 2. Fine. So now you guys try out 1 or 2 and then I'll solve any which ways. MgCl2. You have the table there, right? MgCl2. I will now switch to the table. Question is MgCl2. MgCl2. You have to write the name of the compound, MgCl2. Magnesium, right? First have the cations. Mg is our magnesium very clearly. Mg2 is magnesium. Yes, and then we have chloride. Okay, so my MgCl2, everybody, very easily. These are magnesium. Right. Okay, now we have FeNO32. FeNO32. Okay, Fe. Yeah, FeNO32. Iron oxide, nitrate. Iron 2 or iron 3? Nitrate has how much power? -1. And two of them are there, no? So that's -2. So this side you need is +2. So this is iron 2 or iron 3? Iron 2, right? So we have here, you see, we need iron 2, and then we have nitrate. Okay, as easy as that. Next is Na2SO4. Na2SO4. Okay, I don't know why it doesn't work. Na2SO4. Sodium, sodium, sodium sulfate, sodium sulfate. Yeah, you have Na here and sulfate here, SO4 2. Okay, so because we have this SO4 2 has 2 negative charge, and my sodium has only 1 negative charge, we'll need 2 of them, right? That is why it is sodium sulfate. SO4 is sulfate, NO3 is nitrate. Wow. Now we go CaOH2. OH2, I've written it over there. Yes, calcium hydroxide. Because calcium has +2, we need 2 hydroxide to make it 0. Okay, so that's why it is CaOH2, not CaOH. Right? There is nothing called CaOH. It will be always CaOH2. Calcium. Calcium hydroxide. FeSO4. Iron sulfate I know, but iron 2 or iron 3, bhai. Sulfate may you see how much power is there. SO4 has power -2. Iron will be also +2 is required, right? So this is iron 2 sulfate. Okay. In case of iron, copper, etc., you have to see whether it is 1, 2, or 3, 4, like that, right? So we have this. See, the correct answer will be iron 2 and then sulfate. Okay, fine. So now let's do other way around. Barium sulfate. Barium is Ba2. Okay. If you don't know that, this is Ba+2. Okay. Barium sulfate formula. Barium is Ba+2. Okay. It is not here in this table. Yeah, Ba2, 2 plus. Sulfate is how much? SO4 2. So what would be the barium sulfate look like? Barium is Ba+2, right? And sulfate is SO4 2 minus, correct? 2 minus, no? Sulfate. SO4 2 minus. So how many we combine? 1 1 1 1. What will be the formula here then? Ba BaSO4. Okay. Next in line, magnesium nitrate. Magnesium nitrate. So this is magnesium, Mg how much? Right? And nitrate is which one? NO3. With how much charge is there in nitrate? Right? So what will the formula to make it 0? 1 Mg, yes. And nitrate how many? It is a -1 charge, nitrate. We need -2, right? How many nitrate required? 2. So MgNO3 whole 2. See there, right? 2 of the nitrate is required. Okay? Sodium acetate. Sodium acetate. Yes, okay. Just a moment. He's saying sodium, Na plus, and acetate, CS3, COO minus. CS3, COO minus. See here. Yeah? How many we combine? So we can write it like that. Yes. CS3, COOH, Na, or Na, double OC, CH3, like that, right? Usually for the carbon compound, we start with the carbon chain, CS3. That's why I've written it like that. Okay. So that's what we have to do. Okay. You're getting the idea? Okay. Now write the formula for compounds produced by combination of each of the following pair of elements: sodium and bromine. We have to combine sodium and bromine. Okay. So sodium is going to be my Na plus, and bromine will come from bromide, right? Because anions, bromine is bromide, ide is what we say to the anions, right? So this is Na plus and Br minus. How do we combine Na plus and Br minus? So we have this sodium, which is Na plus and Br minus. How do we combine them? 1, 1, 2, 2. NaBr. Fantastic. Magnesium and bromine. So Mg2 plus, right? हाँ. So my Mg charge 2 है. Then bracket में Br how many required? MgBr 2. Okay. That's your magnesium and bromine. Now we have sulfur and oxygen. Sulfur and oxygen. Will they combine? Oxide is -2 and sulfide is? Sulfide is how much? Again -2, no? So both of them are anions, so they will not combine. You understand? So no compound will be formed here. Sulfur and oxygen, no compound. Now we go calcium and oxygen. Okay. Calcium, oxygen. Oxygen will give oxide, right? So calcium is Ca2. Calcium. Ca2, just a moment, let me write it down. Ca2. How much charge? plus 2, right? Sorry. So Ca plus 2. And oxygen is how much? O2 minus. Okay. We have O minus 2. The simple will be, what will be this? CaO. Okay. CaO. We have this calcium and oxygen. CaO. Next is potassium and sulfur. Potassium and sulfur. Potassium is K plus and sulfur is sulfide S2 2 minus, right? Okay. Okay. So how many Ks are required? How many S is required? K2S. K2S, right? To make it 0. Aluminium and bromine. Where is aluminium? 3 plus. Okay. Aluminium is 3 plus. Okay. So we have Al plus 3. And bromine is what? Bromide, right? Br. So how the combination will look like? AlBr3. Okay. Can you see this? How this is forming? Very easily. And then yeah, it is fine. The way you want to understand. Okay. Okay. Now we have 3 or 4. We can do very quickly. Calcium carbonate. Okay. Major compound of a coral, sea shell, limestone found is anti-acid preparation. Okay. So the limestone or coral which you pick up on the sea beach is calcium carbonate. I want a formula for that. Can you give me the formula for calcium carbonate, please? Okay, so calcium is Ca plus 2. Okay, I'm going to write with the charges first. Okay, calcium will be, and carbonate, we have to see carbonate. CO3, 2 minus. Okay, so how do we combine? CaCO3, as simple as that. Yeah, plus 2 minus 2, 0. CaCO3. Fine. So that's your C cell, that's CaCO3. Now we have magnesium hydroxide found in the milk of magnesia. Okay. Just a moment. First, we go to magnesium. Magnesium has how much? Mg2 plus. Okay. So Mg plus 2. And my hydroxide is how much? OH. OH minus 1. Okay. OH minus 1. So what should be the formula? MgOH or something else? MgOH2. Because you need 2 hydroxide to neutralize our Mg, right? So this is going to be MgOH2. And the last, or second last, sodium hydroxide. Sodium is how much? Na, and hydroxide is OH. So this is simply going to be, okay, last. Zinc oxide that is used to protect from sunlight and ultraviolet ray, that is there in the cream. Okay, sunscreen. Zinc oxide. So zinc is how much? Zn plus 2. Right? This is Zn plus 2. And oxide is how much? O2. Yeah, O to the power minus 1. Sorry, O minus 2. So zinc oxide is going to be simply Zn. Wow. So that was easy. And because we have a no homework policy, so I'm not giving the homework. These are the questions we'll do next time. Okay, but our expectation will be to do it faster. So please redo the problems. This video will be saved on the Google Drive. The link is already shared. If you want to rewatch the video, you can watch it, right? But this will be really helpful. I think this is in class 8 or class 9. And we have done much more than that already. Okay, fine. Any doubts? Okay then. Thank you very much. Enjoy. Huh. Okay, so those are called space filling models. So those are like balls, right? Showing the whole here in the ball and stick model, you have a stick which shows bond. Here in the space filling model, this is the red one is oxygen and two white one is hydrogen. So this is just a representation of that three-dimensional structure of the molecule. Okay.